Network interference affects the overall experience of phone and internet users. Choosing the correct base station antenna can contribute towards a solution. What is network interference? Networks are built using multiple base stations. Unwanted radiation from nearby cells can affect local transmissions. A poor antenna design doesn't help, as antennas can create unwanted radiation, and therefore contribute to network interference. Knowing how to choose the right antenna can help. The first step is to understand how an antenna can contribute to radiation. An antenna radiation pattern consists of two parts: azimuth, which describes the pattern emitted by the antenna in the horizontal direction, and elevation, which describes the pattern emitted by the antenna in the vertical direction. Some of the antenna radiation pattern is unwanted, and these parts exist outside the main beam and are known as side lobes. Upper side lobes are the main culprits. Due to their greater angle, the upper side lobes have the potential to travel further. The blue arrow shows this clearly. Therefore, this signal can reach distant cells which use the same frequency. Proper suppression of the upper side lobes minimizes this effect. Suppressing all upper side lobes across the antenna tilt range can only be achieved when all radiators in the array have their phase independently adjusted. Antennas that adjust the phase in element pairs compromise the upper side lobe suppression and generate lobes as high as 11 dB below the peak. Alpha's PCB-based feed network suppress all upper side lobes, thus greatly minimizing the possibility of antenna-driven interference. A network operator in a major European city replaced existing antennas with Alpha wireless parts. The existing antennas, unlike the Alpha parts, only suppressed the first upper side lobe. They experienced a reduction in interference, and as a result, a network throughput improvement of up to 30% and a sector capacity increase of up to 12% in certain areas of their existing network. Correct upper side lobe suppression was identified as the primary reason. The city map shows in blue the areas where these improvements were detected. In conclusion, choosing antennas which suppress all upper side lobes helps reduce overall network interference, thus improving network throughput and sector capacity.